presentation is really about the implications for people and for policies, and not even so much about what kind of policies we need as how do we make those policies, who makes the policies, and how do we make choices. So really that is the idea behind this presentation. I'll start. It's not at all a technical presentation. I have mainly photographs, maybe some charts from some studies, but mainly photographs. And I'll step away from the Himalayas. I know this presentation, this whole symposium is about the Himalayas, but for just 2 slides, if you could permit me, I'll step away to other parts of the world, first to Antarctica and then to Africa, and then come back to the Himalayas. So this picture is actually taken from by my former colleague who had a chance to visit Antarctica. And on the left, you can see snow which has turned red. And this is actually a warning sign of global warming because there's a particular algae in the snow which changes color, changes pigmentation in order to protect itself from warming. And that's what gives the snow this appearance of being blood red. They call it watermelon snow. And there's a study by Lutz et al. 2016, which shows how the number of watermelon snow sites has increased over the last few years as an indicator of climate change. This also has a feedback effect because the albedo effect is less when the snow is darker rather than white. The picture on the right shows a very grassy land, very, very different from what you imagine Antarctica to be like. So my colleague was very surprised. And the reason why there's so much grass is because there's nitrogen trapped in the ice and snow, which when the snow melts because of warming, this nitrogen, in fact, acts as a fertilizer. And so you have grassy land rather than icebound as climate change is happening. So this is just a sign of glaciers all over the world actually melting. And in the case of Antarctica, we know that, in fact, the ice sheet is melting from below as the ice comes into contact with warmer ocean water. So it's actually far more complex and far more imminent almost than sometimes the models can capture. This picture is from Africa, and you can see the locusts in the field. And this again is an example of how in 2019 we were affected by multiple compound climatic events. Because the monsoon in India was delayed and conditions were such that there was more moisture in the air, these locusts, which usually start from Africa and continue to Afghanistan, Pakistan, because of the pandemic, the pesticide spraying couldn't happen in time. The monitoring surveillance wasn't happening as usual. And so these locusts crossed over, reached almost Madhya Pradesh. In fact, some even reached Mumbai. And this was just an example of how our world is so interconnected and how we are getting these compound impacts. We had, for example, in 2019, this locust attack, the pandemic, a cyclone, many more things. So with that, let me come to the Himalayas, but with a slightly personal story. So this was my daughter who went to Triund in 2019 summer. And she's almost about to cry over here, you can see from her face, because she had hiked up to the top of Triund because she was hoping to see snow for the first time. And that's where the snow line is supposed to be. And that year, she was on reaching the top, she was told that the snow was still 7 kilometers away from the snow line, from the typical snow line. And she came back and told me, "Mommy, this is climate change." So just wanted to put in a personal story there and say that, the thing is with the Himalayan states that we have, there is so much that is changing. It is not only climate change that's changing, but it is also there's migration, there's urbanization, cities are growing, hydropower is being built, roads are being built, cropping patterns are changing. So when we study climate impacts, even though our models may look only at the scientific elements and try our best through the models to capture reality, reality is always far more complex and far more interlinked and far more personal. Many aspects of climate change, for example, are very well known, like the fact that apples in the Himachal Pradesh, this is like one of the earliest, very well known examples of climate change. A lot of people will tell you about it. But there are, so many other issues that are happening. And glacier melt is one which has really caught the attention of a lot of people. And you've all been discussing how to model glaciers, a glacier melt, the Karakoram anomaly, because some glaciers are not retreating at the same rate. I just wanted to mention a couple of studies over here. One is by Moria et al., which found, a new data set of satellite data from the Cold War era when Russia and US were, spying on each other. And they used that data set to find that the ice loss in the Himalayas has doubled in the last 40 years. Another study by Rowe et al. Is saying that, maybe 100,000 years ago, there was somewhat melt of glaciers in the summer when the northern hemisphere was tilted towards the sun. But now the response rate is so fast that earlier you could say maybe 25% of the glacier melt could be attributed to anthropogenic climate change. And now it's almost as if all of it is due to human induced climate change. I also vividly remember a presentation made by Scott Overbeck, who studies tropical glaciers. And he said that when he went up to one particular glacier, I think it was in Latin America, the glacier had retreated and there was fossilized evidence of plant matter from hundreds and thousands of years before. So there was plant matter there before. The problem is that now the rate at which these glaciers are melting is so fast that we are not able to really cope. We have never seen this kind of rapid response rate in the past. But glacier melt is of interest to not just scientists, but also to economists. And those of you who read Times of India or Economic Times will be familiar with the weekly column of Swaminathan Ankleshwar Iyer. And a few months ago, he came up with a very provocative piece saying, yes, glaciers are melting, but there's no need to panic. And he's basically saying that, government of India need not worry about it and so on, and encourage you to go and read the piece because he's actually reviewed 3 different studies. And I'll just mention those. And the studies that he's talking about are trying to estimate what is the downstream impact of glacier melt on river runoff, particularly for the millions of people who live in the plains of northern India. There is a oft-quoted study by Imazil et al. I think there were a number of papers which found that as much as 40% of river runoff could be attributed to glacier melt. And so basically what they're saying is that what happens in the mountains will affect millions of people downstream. Another study by Yu et al. Puts that sort of share of glacier melt at 19%. And the study that Swaminathan Ankleshwar Iyer writes about in his article cites another study by Armstrong et al., which says only 4% is because of glacier melt. And he says that that a lot of the confusion is because snow melt and ice melt have been mixed up. And finally, monsoon rainfall will account for the majority, the bulk of the river runoff downstream. And so India need not worry, even if all the glaciers melt, only 4% of our river, Ganga and Yamuna river water comes from the glacier, so we don't have to panic. Now, is this a valid inference? Even if this methodology is correct, there are glaciologists like David Hanna in the University of Birmingham who've said that it's very hard to model glaciers that are covered with debris. And also that, what you may get is seasonality. So river runoff may become more spiky. There are people who are saying that, in the summer, for example, the dry season before the monsoon rains come, if you have shortage of rainfall, then you would need to basically cope with that. You would need to prepare for that, maybe having some kind of water harvesting structures. When you need a little water in the hot, dry summer season, particularly with temperatures rising. So this is a very kind of complex issue. And even if you look at the studies that look at glacier melt and downstream river runoff, there are other issues. For example, what happens to the agriculture that depends? This is a picture from, 15 years ago that I think I had taken when I was doing fieldwork in Uttarakhand, in Lakwar district and Chakrata district of Uttarakhand. And you can see, first of all, how small and fragmented the land holdings are. This is terrace farming. It's all almost entirely rain-fed. This particular picture, I don't think you can see, but this is actually water that is just falling down, and this will be used to irrigate the fields and to run a little mill. So this is the nature of the agriculture in the fields, and those of you who are from this region or who are familiar with, with this area, will know how hard it is, how difficult it is to make a living from agriculture in this area, and how widespread the migration is. So we need to take into account what will be the changes because of snowfall change, early snow melt, rainfall change, mountain stream runoff change, all of this on people who depend on agriculture here. When I spoke to people in this area, they used to say that in the early years, like if you spoke to an elderly lady and she said, when I came to this village as a bride, the snow was like manure. It would settle and it would enrich the soil, and now it's happening earlier in the year. Similarly, if you think of mountain streams and even the insects, the aquatic insects that have their habitat, what will happen when the stream water becomes a little warmer? What will happen with the meadows in this area? This picture, actually, these daisies are an invasive species. They don't actually belong over here. But the point is that it's an entire food chain, an entire ecosystem, and livelihoods depend on it. So, for example, pastoralism is something which is very important for this region, and we don't actually take into account in really any part of our country what would be the implications of these kinds of climatic changes on the communities that depend on them. Let me give you a slightly different point right now. A lot of people, I'm sure, are aware that, growing extreme rainfall events, landslides, even glacier lake outburst flood events will have major implications for hydropower that is being built in the mountains. Maybe that infrastructure needs to be made more resilient. Maybe you need to spend more in order to raise the height of these dams or strengthen and fortify them. But actually, water is important for all kinds of power plants. Thermal power plants, for example, use a lot of water for cooling. You can see that there aren't any thermal power plants in, say, Himachal Pradesh or Uttarakhand, but in the plains, there are a lot of thermal power plants, and these depend on fresh water for cooling. The red and dark red areas are those areas which are already water stressed. And so, the point that I would like you to take away is that what happens in the mountains will have implications not just for natural resource based livelihoods in the mountains, but also for the energy security of the entire country. I'll now talk about, I'll just show you three different charts or maps from a database. You're most welcome to look at it. It's by my organization, World Resources Institute, and it has a lot of publicly available data sets. But let's look at what happens with tourism, for example. These are the major tourism sites of Uttarakhand. We have religious tourism, we have hiking, trekking, adventure sports, wildlife tourism. But for example, the Char Dham Yatra is something which draws crores of tourists every year. So you have Yamunotri, Gangotri, Kedarnath, and Badrinath as growing tourism sites. The size of these circles represents the number of tourists. And these blue lines are basically the water basins, the drainage of the rivers. So you can see that all of the important tourism sites of Uttarakhand are located along these kinds of rivers and streams. These red dots show you where landslide events have happened. This is slightly dated data. It's from 2015. It's not up to date. But you can see that, you are basically having a kind of juxtaposition of growing numbers of tourists coming to areas where the hazard is also growing. So these are landslides. And this slide basically maps the baseline water vulnerability. So water scarcity. Red obviously means more stressed. Yellow means less stressed. It's not taking into account future changes because of climate change. Because it may happen that in the short run, there may be more water available, and in the long run, there will be less water available. There would also be seasonality differences. But here, what you have is a juxtaposition of three factors: existing water stress, existing landslides, and growing numbers of tourists. So, this is something that is very important when we try to build the economy of the mountain regions based on industries like tourism and hydropower and road development, all of which are highly vulnerable to climatic hazards. Let me now just spend a little bit of more time talking about agriculture vulnerability. And as you can see over here, roads are really a very important bottleneck for making sure that, for agricultural prosperity in this region. Unless farmers are connected to the markets, they're not able to get the right prices for their produce, and they're really not able to make a profit from farming. So road construction is definitely very important. Market access is extremely important. But in the way of how we build these roads, where we collect the material from, do we give adequate safety measures, when the road construction is happening? All of this becomes extremely important. So as I said, around 2005, I did fieldwork in a few villages in Uttarakhand. And what we were trying to do at that time was a couple of things. We were trying to share with them climate science, like climate model results for this region, both in terms of temperature rise and rainfall rise, but also the results of, say, SWOT model results for river water runoff. And we wanted the community to understand what these future projections were saying for 30, 50, 100 years from now, from that time. And then to say, does this make sense to you? Does this relate to your lived experience? And if this is what the future will bring, then what kinds of adaptation options would you recommend? So this is actually a group of women who were looking at this. And I wanted to spend it, because this is really my second last slide, I wanted to spend a little time talking about the impact of these kinds of climatic events and socioeconomic impacts, particularly from a woman's perspective. First of all, we all know that women, especially in the mountains, spend a lot of time collecting firewood and water. And if these kinds of resources, natural resources, their scarcity grows, then there will also be more competition over scarce resources, and there could be inequity in accessing these scarce resources. So that's the general kind of perception with which development organizations design their interventions. However, it's very important to use the right kinds of gender metrics. Usually, people go in talking about time taken or distance traveled as a measure of women's work burden. I wanted to mention two studies. One is by a former colleague of mine from Terry, Deepthi Chatty, who was doing her PhD in Yale. And she was looking at a couple of different locations, Himachal Pradesh in the north, and I think Gadag district in Karnataka in the south, and looking at how LPG access is improving women's access to cooking, and hence perhaps even their health implications because of air quality. Yeah. So what she found was that in Himachal Pradesh, the process of firewood collection tends to be a seasonal activity. It is not necessarily a daily activity. Women can collect, 2 to 3 times during the season, go and collect large amounts of firewood and store it in the house. Use it not only for cooking but also for warming the house. So it's a slightly different way. And when you try to basically replace firewood by LPG, what is important is not just the first connection to LPG, but also is it easy? Is it affordable? Is it not very time consuming to get the cylinder refill? And here we find that it is men rather than women who are able to access, to spend time in the depots in order to get the LPG refills. So again, what I'm trying to say with this example is that the picture is a little complex. In South India and Gadag, in a highly drought-prone district, the scarcity of firewood changes the equation completely, and LPG is becoming actually very important. So all these kinds of national policies sometimes play out a little differently depending on the natural resource context of the specific state or district where it's being implemented. The second example I want to give is from Vishal Narayan's work in the foothills of Himachal Pradesh, of the Shivaliks, for water. And there, a kind of intervention was designed where they said that instead of women having to go to the river in order to fetch water, let us install hand pumps in the village itself. And that will make women's life easy. Instead, it was found that women's work actually increased, because when earlier men would go to the river to bathe or to bathe their cattle, now they expected that women should go and fill water from the hand pump and bring into the house for their bathing. So actually, the women's distance travel became less, but the time and effort became more. So just wanted to give these as a couple of examples of how policies play out on the ground. And this is really my last slide, which is, I started by saying, what is the impact on people and what is the implication for policy? Finally, it is the people themselves who should be able to feed into the policy making by saying what kinds of interventions would be the most relevant for them, how they need to be designed and implemented in a way that they are effective. And one particular approach that we had over here was really participation in a kind of visioning exercise in looking at different scenarios. There are also other efforts that I'd be happy to talk about if there are questions, which we did in Assam, where we did even things like group model building, where we brought into the same room officials from, say, the disaster management department, the water resources department, indigenous communities and farmers and others, and as well as academics from IIT Guwahati. And they participated in their own kind of conceptual modeling of what causes floods in the upper Brahmaputra Valley. And when they heard each other's diagnosis of cause and effect, they found they were completely different. The local communities were giving a completely different diagnosis than the academic engineers, and the government officials responsible for compensating people were coming up with a completely different diagnosis. When they heard each other, their perceptions changed a little, and then they went back and redid their models and came up with different solutions. So that's really, I would say, the way forward. Doing research that is not only disciplinary, not only interdisciplinary, but transdisciplinary, which is involving the affected community, the affected stakeholders, right from the problem definition stage itself, and using that to guide your research. So let me close with that and thank again the organizers for giving me this opportunity to talk about some of my work. Thank you.